Well, it's nice to meet you all. I'm Mike Driscoll. I'm with AT&T, their CSO office, where I head up and lead advanced analytics and data science for purposes of cybersecurity. Today, I'm going to take you through our journey to deploy end-to-end machine learning algo to detect cyber threats and help prevent fraud. To start with any journey, at least to set yourself up for success, it's always good to be clear about what you're attempting to accomplish. We set out to say, hey, we want to be able to classify and score network activity. Not just find the bad guys, and we want to find the bad guys, but we want to be able to be able to determine who the bad guys are, and we need to be able to know who the good guys are. So there's a number of challenges that come with that. None too small. Start with new technologies are leading to new and uncovered vulnerabilities, and that's a continual issue. Keeps us employed. Two, the frequency and intensity of these attacks have been further fueled by high-performance computing, amongst other things. And the attacks themselves, because of these elements, change their signature. They're not static. So, coming back to what we're trying to accomplish, right? We're trying to identify and weed out the bad guys. So what's some of the considerations when we think about the problem? One is the size and complexity of the data and computations. It's not small, either in data or in computations. Think about how many times you use your phone. You want to connect to the network. Now look around you, still thinking about that, and then think past that. Second consideration is, as they're getting faster and smarter, the window in time for which we have to respond is shrinking. How do we get the decision and how do we push it out to the edge? Right? The sooner we stop it, the less likely it is that they're going to be able to compromise an account. Third, because these guys are shifting and changing, right, we have to adopt some form of continuous learning. One that can allow us to identify these shifts early, change points, right, and then react. Ultimately, though, for our end purpose, to connect and protect our customers. That is our top priority. So, when we think about our journey forward, as we thought about our journey forward, there's lots of ways of approaching the problem, but we wanted to set out with some first principles. So what were they? To start, let's adopt a data-centric approach to AI and ML. Why? Go back to the considerations. Size of data and computational complexity. If you're not thinking about that today, and you start down that path, you're going to be doing a lot of rework. Trust me. Second, with all that data, there's a lot of dimensionality issues. I mean, sort of the curse of dimensionality. Guys in Los Alamos will tell you that they think they've solved that. They're not. But statistical scoring and graph metrics are a big component to informing us in terms of how things should be classified. Ultimately, this all has to be done continuously. It's not a one and done. It's changing. So it's a continuous search for connections for us to know our customer. It's probably the easier part, right? We're in business because a large percentage of our volume are the good guys, thank goodness, right? And what we're looking to do is flag the bad guys, the fraudsters, the guys looking to perpetrate some terrible act. Leave it to you and imagine what that is. So when we come back to the principles and where we're starting, I said, this is all easier said than done. Where we started out is with data. Ultimately, We want to be able to leverage our data and do so that we have a different perspective, and we can have different lenses from different angles all the time, right? You know, if you're driving down the road and you're only looking down one, but you don't look behind you or on the side of you, you start to make a decision. The outcome may not turn out too well. We have to be considerate of that, right? So we go about collecting, I mean, this is historical, so it's not new, collect data that we use to inform our decisions. And those go around a number of core segments. Again, try to keep it simple, right? So user and account behavior, network logs. Everyone's heard about network logs. There's lots of them, right? Network information, domains. Authentication logs. So, well, you know, what's been the journey? What's been the events? You know, when you see a transaction walking through the network. And then, you know, lastly, right, threat and fraud intel. There's plenty of resources for that, including the dark web and historical fraud events, historical breaks that we have that inform us a little bit about both the techniques that are being used, the approaches, the points of access, you know, a little bit about the how and the why. But what do you do with all that data? It's not small. It's not small in terms of volume, and it's not small in terms of metrics. And if you try to process all that, well, you might not get to an answer. So come back to where we started. How do we simplify the problem? You know, where we can continuously learn, not give up information, right? But not take information that's not giving us any lift. So, as I mentioned, the feature space is large. By the way, the distributions on any one of these metrics are heavy-tailed. So there's no normal bell curves here. And we have two needs. The first is, how do we define normality? I mean, like I said, remember at the onset, we said that we're in business because large volume, large traffic is the good guys, right? So we should be able to tell who they are. Maybe that's a starting place. Right? Second piece is, and I just touched on it, you know, the data is voluminous. There's many metrics, right? How do we reduce the dimensionality without giving up the information? Tough question. Right? There's been a lot of talks past few days about different approaches to it. I'll tell you about some of the things that we've considered. And again, it's ever-ending. So, a few comments on the approach. First, mixed models can and are used, right, to estimate unidirectional distributions. So this helps us with the first part of the problem, generating distributions or signatures that we can use, right? But we've accounted for those tails. Two, the metrics are then, it can be evaluated and ranked in terms of their information importance using dimensionality reduction. Now, dimensionality reduction has been talked about. It's been around for many, many years. A lot of this stuff, by the way, is new. In fact, most of it was written in the 50s or before. We just have the pleasure of having the compute resources now to do something about it. But we use dimensionality reduction to generate scores. Of course, as an example, for segments, volumetrics, that's something that's well known by probably everyone in this audience who's done any work in cyber detection, right? It's the old rules of how many counts, how fast are they coming in, how many distinct users is this, say, you know, password spreading event, is it the brute force attack, right? There's certain characteristics, right? I'm not looking to necessarily measure any one of those because, as I mentioned on the onset, right, they're always changing. I come back to the premise, right? Most of our traffic's good. We should be able to detect that. So all we got to do is find what's bad, what's not normal, what deviates from what we're going to call the norm, and then see what other characteristics you can combine with that to confirm hey, this is a bad guy. Let's do something about it. So, like I said, a number of different forms of dimensionality, the simplest of which is PCA. I think we're going to find at some point in some graduate class or undergraduate class the PCA decomposition to help with importance. But also there are other metrics that we can use, including graph metrics, and various forms of clustering and unsupervised learning to help inform on that. These signals, though, that we get can then, with this dimensionality reduction, be aggregated and done so in a way to measure what I like to call the rising tide of something deviating from what we're going to call normal. Now, people talk about anomaly detection. I like to think about it as normal detection. And this does allow us to define what normal is, and also allows us to define when we're deviating from normal. So combining these scores, and now going back and recombining these scores with all the features that we've collected, we have the ability to then inform clustering or some form of unsupervised learning to label the data. What? Someone say label data? Yep. We did. So that takes us to the next piece of how we get there. And I'm just giving you sort of I think it as a recipe. By the way, it's a little recipe. But in the simplest form, what we gain out of the process is two things. One is the risk category. So, is it a known customer? Is it suspicious, or is it a bad actor or fraudster? Right? And then around that, you have a risk score. I call it a risk score, but really it's kind of a measure of certainty. Right? How certain am I that what I'm measuring here and how I'm classifying it really is what it is? And if I'm wrong, right, what's the likelihood of being wrong? Now, why do I ask that question? We need to take care of how we provide network access, right? And so we have to have a very high level of confidence. And so when we apply our decisioning, we're taking this information in consideration. And we're doing so in conjunction with other information that is provided to us along the way by collaborating with our partners on the threat teams and other parts of CSO, fraud teams, and other parts of the organization, broadly within AT&T. So that's how we go about doing it. That's sort of the recipe that you get there. And mind you, this is not something new to AT&T. We've been doing this all along. We have to. That's our job. Right? Provide access, connect people. What we're doing that's different and better is that we've moved from rules. Why? Well, remember, the guys out there are smart, right? They can get around rules. We all know that. So if we don't keep up, we can try to continue to update those. But that's not foolproof. Now, it doesn't mean we take those rules and throw them away. No. A lot of work to get there, a lot of analysis, right? Rather, we're enhancing it with ML. It's a tool, right? And that's what we've done. Now, rate, coming back to the third point that I had raised earlier at the inception of the discussion about our journey, what were the considerations? Lots of data, lots of transactions coming through, milliseconds or hundreds of milliseconds, right? And with that, we have to make a decision. So how do you do something so complex that I just talked about and deliver it in real time? Well, I could say a technology stack, or I like to call it playing with the toys. And seriously, though, we can deliver and identify classified traffic in milliseconds, and we do so. And how do we get there? It starts coming back to where we began the story, which is thinking about the complexity in terms of the size of the data that needs to be processed and manipulated and translated. And so we start with the streaming from our network event hubs and enriching that raw data to distill into those metrics that I was talking about before. And we use a series of, technologies, Spark streaming, Kafka, Flink, amongst others, right? And by the way, as we do this, as we deploy technologies and as new technologies come into play, right, we've built a framework where we can plug and play. I said plug and play. Well, we always want to get there faster. We considerate of that. And so we need to be able to quickly and nimbly test things out in dev and then ultimately be able to roll that out in production. So bringing the data in is one piece of it. And then doing the feature engineering and ML training is the second piece of it with the prediction. And there we use a combination of technologies, including, Databricks for Delta-like tables within a warehouse for that, so generating those pipelines, to Kubernetes and the feature store with, when we partnered with H2O, and then ML flow for orchestration. The results then for this last piece of the story, but the important piece of the story, because that's what's going to generate those alerts. And when we generate those alerts we're not the only ones looking at that. I mean, clearly we need to monitor what we're doing and to make sure that, where it's behaving the way we intended it to, whether or not there's been any model drift, whether there's been any change in the data streams, whether there's been any disruptions. That just goes with it, right? So we'll use things like SQL editing to do that. But we have partners in the business that depend on us. Fraud, customer care, operations. They need to know too, and management needs to know. Well, what's going on here? Oh, and by the way, we get a call, right? Something's up, right? We need to be able to have that information there real time. This is why this decision was made. This is how we've attributed. This is the validation and verification. So we do that, and we then distribute that and visualize that using another series of technologies, whether it be Splunk, which has been used within, across this industry segment, Power BI, it's a nice tool, and then Streamlit for streaming to see what we're seeing in real time as it's developing. All of them, right, complement each other. There's no one solution, right? That's the point. I say toys in the chest, right? It really is a little bit, right? Because you don't really know when you get at the onset of things what's going to really work. You hear about other people's experiences and stories and what worked and what doesn't work. And we still continue to go down that path. So I think that when you all are considering or thinking about how you approach this problem, and by the way, the techniques and approach that we're taking here is not useful, not just cybersecurity, so many other things useful. It's just some of the lessons that you learn from it in terms of how you approach the problem and how you enable yourself strategically as an organization, right, to be able to shift and change and react. So, look, let's come back to the top of the journey, right? I always like to ask the question, so what, right? Remember, getting started, all right, means getting buy-in, getting senior leadership to say, yeah, we want you to do this, but, prove it to me, right? And so that really pushes to the question of defining your metrics up front, okay? But in our case, authentication success rates is a big piece of that, right? We want to know that when our customers are trying to access our network and we're trying to provide them service, right, that they have a very high rate of authentication success, right? And that we have a high ability to detect when the bad guys are coming to play and do something about it. Well, look, there in milliseconds we're delivering. We are doing real-time detection. What you're seeing here in this graph, it's anonymized in certain ways. A sample month of traffic. You'll see that the traffic is being scored. I'm only showing you this on a daily basis, but you'll see the gray, the yellow, the red. So that's that progression from The good is kind of warming up a little bit to, oh my God, we're on fire, let's do something about it. And then ultimately at the end, you see the impact of remediation, bringing us back down to more normal levels. Now those actions, that in itself, how those actions to remediate, that's another part of the story. There's another part of decisioning. There's another part of information, right? Because remember, we're trying to always push to the edge, and there's different parts where you can access our network and authenticate through our platforms. We know that. And when we have a high certainty of knowing you're the bad guy, right? We're going to take care of you right at the onset. So, the benefits are pretty clear, right? Our known customers, you all, right? You're benefiting because we have reduced frictions, and thereby allows us to accelerate events and delivery of services. That's key. Classification leads to an accelerated highway to connectivity, and that's really sort of at the top. So coming back and just kind of wrap up a little bit, and I don't want to spend too much time. I do want to touch on a few things about some of the challenges and some of the paths for resolution. Data labeling and developing a truth set. This is something that's something that everybody in pretty much any industry struggles with. Now, we struggle with it a little bit more just for some of the reasons I mentioned earlier, which is that the signatures are always changing. So what is your truth set? Your truth set today may not be your truth set tomorrow. How about that? Analysis review and attribution is a good way of helping sort out some of that. But also reinforcement learning and generative AI can also help with that. Unified data platform, really to drive our data engineering. So remember, I said we're gaining all these different sources of data and platforming them in real time. And why? So that we have different lenses from which to look at, a prism almost, of that risk. So sourcing and integrating and being able to do so on the fly is an important aspect of how you architect that. And the feature engineering of new threat intelligence is a big piece. That having a unified platform and doing so in real time, and not all of it means necessarily need to be in real time. Certainly the stuff for which you're using for decisioning does. But when you're thinking about building or refining, whether it be a rules-based algorithm, and I think there's a lot of merit to that, or trying to improve or enhance an ML algorithm, you need data. And so you create anonymized, structured and curated data with very clear governance, by which that's accessible within our organization to retrain. Explainability, model and platform. I think I touched a little bit on that earlier, but just to reiterate, it's a big piece of machine learning or statistical learning. Can you attribute your results? Now, in my many years in the banking industry and having dealt with regulators quite a bit, champion challenger model is a good way to go. And keeping it simple, right? You may have the most complex deep learning model in the world, but if you can't explain it, you're going to get that kind of glazed over look of like, well, thank you very much. But if you have a simple model, right, that validates what you're doing and you can then explain it alongside that or have that model basically reinform, you just hit a home run. You've changed the level and the nature of the conversation that you're having. Lastly is generalizing what you've done, learning from the work that you've done. You can start with a segment of business, right? Say, okay, we're going to try this here, but you don't want to have to rebuild the next go around, right? So that's why at the very onset of this discussion, I started with the question, let's set out some principles, right? Remember the principles? So data first, right? Thinking about how to simplify in terms of dimensionality reduction, and then lastly, continuous learning. Those pieces are key, and once you've done that the first go around, you have that platform, then, well, guess what? It's like Legos. You have to do a little bit of work, but it's more like Legos, which is what it should be. So organizationally, resources, all important considerations, right? It's good. Bias in data and algorithms. Look, any statistical algo, machine learning, deep learning, they suffer from that, right? But your algo and its representation is only as good as the data by which you feed it, right? So that means, right, data governance is an important aspect of this. Understanding and benchmarking the data that you have, right? Who am I looking to approach and apply this to? Is the representation of the data I have in the cohorts for which I'm training appropriate? Are they themselves biased, right? So those are some of the considerations. They're not all. But I did want to share some of that with you. I do want to thank you for attending this discussion today. I hope you may have all found something here that was of interest and perhaps as exciting as I see it every day. I do like getting up in the morning to work on these problems, so it's been a lot of fun. So with that, I want to thank you. Certainly, if anyone has questions or things that they'd like to address, leave it open for you.